Let's get started. Hi, I'm Aaron Wilson, and I'm a senior consultant for AWS Professional Services. I'm on our security risk and compliance practice, and we help enterprise customers operationalize the shared responsibility model you may have heard of. We do this by helping our largest enterprises tailor their governance, security operations, and compliance practices to meet their needs while moving into AWS. Our customers often ask our consultants how to improve their security projects and organization by leveraging popular concepts such as DevOps and continuous integration and continuous deployment. We've seen a few variations on this theme, such as adding security as a fourth discrete component into DevOps, or by embedding security personnel into DevOps workflows. All of these approaches are valid and they work for a variety of our customers, but some customers want to keep security and governance functions centralized and then build security capabilities for their DevOps teams to consume just like they would any other cloud resource. And so I'm lucky to be joined today by Intuit, our Intuit Cloud Security team, one of the customers who's really pushing the envelope in this space. Shannon and Scott are going to work with me today to introduce DevSecOps. This is a centralized, scalable, cloud-ready approach to enterprise security and compliance for the cloud. They'll share some of the stories about Intuit's journey to the cloud, explain the purpose and benefits of DevSecOps, and provide you with everything that you need to get your team started in practicing DevSecOps. So this is a 400-level course today. We've got some demos and things ready for you, but we're going to assume you understand the shared responsibility and some of the basics about AWS security.
Now, one of the things to think about is DevSecOps is not rugged ops, it's not visual ops, it's not DevOps plus security. What it also isn't compliance on...
Compliance gone wild.
Compliance gone wild. See, I can't remember her notes. It's not compliance gone wild. It's not security for security's sake. What it is making sure that you're integrated into the organization, making sure that you are embedded, or not embedded, I'm just going to get kicked again, making sure that you're able to be part of the process, not just being able to be a checklist, but you're involved from the start, from conception all the way to management and maintenance of the product. So you're integrated with the team.
Awesome.
Thank you.
So, would have loved to have seen this speech, this talk, 2 years ago. We've gone through a lot of pain, trial and error, experimentation to really bring to life security in the cloud. You know, it's been a truly head-banging experience for us. We've been bleeding edge in the enterprise cloud space for quite some time. Intuit's been doing cloud security for several years now. And when we first got started, we had all kinds of recommendations, advice, and basically it started out with, hey, why don't you guys try and embed into DevOps? And so if you think about that, it basically means that security folks with their specialties of access and application security or incident response have been asked to basically now be part of an application team to bring all of security to that application team. So we learned a lot, and basically that's how we've brought to life DevSecOps. So this discussion is basically to help you understand a little bit about our journey, some of the lessons we've learned, the trials and errors, and basically to help you to take the same journey we've taken.
Now, we are the team that has been responsible for managing some of the largest security operations environments, have been responsible for leading some of the incident response of some of the largest data breaches. We've been doing cloud security and cloud computing for years. Does anyone remember early versions of cloud computing, rental hardware? A few of us do. Utility computing, yeah, you know, we keep changing the names. But we realized that we had to build a team of people. And one of the things is we had our own internal team. We were learning and growing our team. There were also areas where we needed to add on. And we brought on people like the Amazon Professional Services team to help integrate with us and work with us in a true partnership. So we have Amazon people working on site as long as other people.
Thanks. So we've organized this presentation in terms of telling the story of the journey. So the journey from DevOps and trying to figure out how security fits into DevOps to ultimately operating with DevOps and DevSecOps together. You'll notice that we've kind of got the screen split here. On the top are essentially a set of hypotheses that we then attempt to validate or disprove using experimentation in the cloud. And you'll remember from Dr. Vogel's and other sessions that experimentation is really easy and quick in the cloud, and the cost of failure is negligible. So we are able to iterate on this timeline fairly quickly to get to where we need to be. We'll keep coming back to this slide throughout the presentation as just kind of a navigation bar, if you will.
So let's get started on navigating. Remember when I said we actually started with DevOps and security? So we embedded a whole bunch of folks into our DevOps teams, application-based security, access, folks that did secrets management, encryption, all of these folks, and they were basically now the embedded resource working on those teams. And what we found was that security people actually work better together because they can actually take their different disciplines and mold them all together and basically come up with solutions for their companies. So one of the things we really quickly learned was compliance checklists kind of fell flat. How fast can you actually apply a checklist to something that's moving to the cloud over automation and basically get some benefits out of it? The second thing we really learned was basically that deployments were all automated and all of our security processes were manual. Oh boy, whew, that's going to be a tough challenge. And then the other thing we realized was the SOC that we had, we thought, well, we could just have a traditional SOC look over all of our instances in the cloud. And that quickly became a hypothesis that had gone bad. Traditional SOC capabilities just needed to be extended quite a bit, and actually the learning that a SOC does is generally morphed around APTs. So as long as we were only looking at instances and inside of instances, we were good. But there was this whole other environment that required us to think about attacks and attack surfaces outside of the actual instances. And then finally, one of the other things we realized was, holy crap, we have a whole bunch of data. What are we going to do with it? They've got all this stuff they talk about now, it's called big data, but we never thought that security was going to need it. Why would we actually have to do those things? And so as part of our efforts, we realized we've got to stand up something maybe like a science function. So we quickly invented this thing called DevSecOps. And DevSecOps was basically this notion that we had to have multiple disciplines come to bear to actually support our business, and as an enterprise, be able to support our business. So we invented some functions based on processes that we knew and realized, well, we're going to have to code, so we need a security engineering function, somebody who can do automation. Hey, this experimentation thing and lean and all of these practices, we're going to actually have to figure out how to do that stuff. And wouldn't it be cool if we actually leveraged AWS to build our tools? Because then when we give advice, we're not just giving theoretical advice, we're giving very practical advice. Security operations became a tenet that we knew we had to adapt and basically change to bring to life a full-featured function. And off of bringing that to life, we realized, ooh, compliance can't be a checklist function anymore. And actually, we were getting events out of all of our CloudTrail data and our streamed events that made us realize very quickly that compliance actually had to become an operational function. That was a big head scratcher for us. How do you take a bunch of compliance analysts and ask them to code and get events and tickets? And so it's been a real journey for us in that space. And then finally, security science. We've got billions of events that come in every day. We have terabytes of data, soon to be petabytes of data. And basically, how do you make any sense of that? Questions like, well, when should we restack an AMI? So that's basically what brought to life this set of tenets that we have established and basically put together some pillars that we could live off of and figure out how will these processes work across our organization. So with that said, let's get on our journey.
Okay.
When we started thinking about the actual pillars that we wanted to establish, the next thing we needed to do was actually set up principles. And as we were setting up principles, we realized, well, we got to probably think different. Customer focus. Developers are kind of running the world now. We don't get to say no anymore. We don't have gates. We don't have approvals. We can't get in their way because, by the way, they actually make money for our company. All right, well, maybe they're important. So we decided that they were important. We were going to change our mindset. We're actually going to try and lean in and help. We're going to try and work the way that they do so we can understand them. The next thing we realized was we didn't scale. There were pretty much thousands of developers in our company. We had something in the neighborhood of 10 people to be able to apply to this problem. And we realized, all right, we're going to have to figure out how to scale. Automation, woo, we got to code. Oh God, we got to code. And then we realized, well, if we're going to code, we got to build some tools, and we're going to have to figure out how to actually make this stuff work. Why not AWS? They've got all these really cool tools that scale, and we've got this ability to actually take manual processes to automation. So that was one of the other tenets we put in place was to actually have a principle of scaling. How do we not have a manual person in the middle of everything? Objective criteria. All right, so here's another one that we kind of stumbled onto. We were giving out these really long reports. You might remember them, the ones from the vulnerability scanners and all of the things that you tell people to do, and it's hundreds of checklist items. Developers really love those things. So with our customer-focused mindset, we quickly realized that we had to help our developers make decisions now. In other words, we couldn't just give them our checklists. We couldn't just turn over our scan reports and say, have at it, guys. We actually had to come up with a way to speak their language. How do I make decisions? Well, we kind of came up with this notion of scoring, and that was really a powerful way for us to engage with our customers. And that brought to life basically the notion that, well, if we're going to score these things, what are we all going to do every day? Maybe we should start hunting. And so the notion of, well, when somebody gets a bad grade, should we go hunt them and actually have some fun and find out more about why they're actually not doing so well? So we did, and basically that allowed us to do proactive hunting. So we're no longer sitting back waiting for things to happen. We're not being reactive. We're actually turning things around and starting to be more proactive. We've had folks actually on our team going out there looking for things in our APIs, actually doing validation checking, starting to amass a number of defects that we can push out to our community. And then finally, we realized it just wasn't enough to wait for alerts and response to come in the door, that we weren't going to necessarily always get notified when something got broken into. We needed continuous detection and response. We actually had to have 24/7 capabilities that we were letting people run through the paces on. And so that's basically what established our main principles for DevSecOps, is that it was now about actually providing very transparent information that was easily deciphered by a development team doing DevOps, so that we could actually scale our capabilities and not have to cause them to become security people.
So when we look at the requirement to scale, we knew we were going to have to automate, right? So we read a little bit about DevOps, and we were trying to figure out how security fits in. So on our first stop on Mr. Toad's Wild Ride, we said we need to figure out automation, and that's probably going to mean that we have to build security as code. Right? We knew that the traditional security organizations were being sidelined, as Gene Kim said, marginalized and sidelined, the business is going around them. So how would we do that? We knew what security code was and how that was done, but we didn't know quite how it would fit in at Intuit. But first, I mean, do we really need to do security as code, though? Because we have these really awesome Word docs, and we've put a lot of our effort into these Word docs. You guys have these Word docs, right? They're properly labeled in case you leave them on a printer in the lab or something, you know, because we take data classification and data handling very seriously. This one's sort of up to date, 2011, it's not too bad. But maybe there's a better way. I'm being a little snarky here, but really this is an example of why security needs to be executed as code. This underscores the concept that Andy mentioned in his keynote, where this document and security is essentially frozen in time. And this is not going to work, and the business is going to go around this, and security teams will just be marginalized. So how do we do this? Well, we know it's easy to do on AWS. It's something that's easily automated, it's repeatable, it's something that we can audit to look at the incremental changes, it's easy to iterate upon and do frequently. And the types of code that we were looking at would probably include things like access policy documents, CloudFormation automation templates. We decided to standardize on the Ruby SDK, the Ruby code. So we probably would have some Ruby scripts, and we even built maybe some custom APIs would be in order. So we built some of those as well. So we wanted to just dive in and say, let's just start experimenting and see what we could automate in terms of building security as code. So the first thing we're going to do is launch a project called Centralized Governance. So the first thing you need to know is that Intuit has about 400 divisions, and they're all full of developers, and they're all building really great products. What we need to be able to do is provide governance across all of those multiple accounts, right? So we started with access control and started with IAM, and we said, let's build a baseline of IAM roles and IAM groups that we can push out remotely to all of these business units, and we'll, of course, include the trust policies and associated access policies that need to go along with those roles and groups. We wanted to use it in a sort of a continuous delivery workflow, so we wanted to make sure it supported Git. And we also wanted the ability to not only do drift detection, but be able to react and choose the way that we want to react when we find something that doesn't quite match up with the approved baseline that might be lingering out there in one of the accounts. So this is a picture of what this looks like, where we've got essentially a hub and spoke model where you have a centralized account that has the ability to reach into these trusting accounts. You can see here we're using something called a sec role or a security role, which is a cross-account role that this admin with an MFA can assume that role in order to run this Ruby script and push. You've got a little collection of icons there that represent the roles and groups. That's the baseline that we're going to push out to those trusting accounts. This is what the baseline catalog actually looks like under the covers. We started with just something as simple as a directory structure, file directory structure, because we knew that would be pretty Git friendly. So you can see we've got folder names here such as role A, role B, role C. Those get picked up by Ruby and interpreted, and that actually becomes the role name. These are obviously anonymized roles, example roles. So we have like the access policies, and we've split those up by service so that you can just open the folder and quickly figure out what this thing is doing. We have a short description README file that we included along with this. It's not part of the AWS API, but we wanted to be able to just use that to be able to parse in other APIs that we might build custom in order to figure out what this role does overall. And of course, with a role comes a trust policy. That's a required document anytime you put a role. So the workflow end-to-end looks something like this. You've got a continuous deployment workflow where you're able to check in, develop, review, test, and approve and commit that code into a source code repo. At that point, you can have the Ruby script periodically pull a copy of that, where then an admin can leverage the long-term credentials in the centralized account in order to leverage the sec role that's out there on the trusting accounts to be able to push that baseline out to all of those trusting accounts. So naturally, we have a directory of all the accounts and all the account numbers, the cross-account roles that we're leveraging in order to hit use the sec role to leverage the connectivity into the trusting accounts to push the baseline. Shannon, what do we do next for security operations? How are we going to make those guys not so static and not so legacy?
Yeah, that's a great question, Aaron. So security operations is one of those interesting things. We brought in a vendor to help us with our journey, and as part of it, we did that because we wanted to partner with somebody who actually knew how to do security operations really well, because we knew we were going to have to adapt it. And so if you think about that for a moment, the vendor we chose was Mandiant. And basically, they've got years and years of experience in security operations center development. And what we realized was we needed to have a tool to do correlation. There was this thing coming called CloudTrail. And we actually realized that, where are we going to get our network events? Oh my gosh, there's no network events. Well, what else are we going to look for? So we realized very quickly that we had to have this ability to take information out of our instances, because that was where things were happening. And we had to instrument those instances, and we actually had to receive that data in someplace that analysts could work with it. And so as part of the journey, we realized very quickly that we needed to think about security operations centers in a different way. So Security Ops Reloaded. Basically, we established some principles for security operations. And this was an interesting journey for us. We first started out trying to do DevOps-related security work, right? And everybody embedded into the teams. We basically tried to have the development team help us with our threat models. They were going to give us these things called spreadsheets. We were going to take those spreadsheets, and we were going to instantly know what was wrong whenever we saw it in the event stream. And then we realized very quickly that that's not quite working. Well, we actually need to threat model with the teams and to some extent have an understanding of the infrastructure before somebody even puts an application out there. So we had to learn. We actually had to go out and look at AWS and understand, well, there's this thing called SQS and S3 and EC2 and EBS. And all these acronyms were pretty foreign to our Security Operations Center. And so it was a mixture of folks inside of Intuit and in our partner that basically sat down and said, well, how can we do this better? Can we apply NIST standards to this? Or how do we actually start understanding how to do this work on a daily basis? We've got tons of information coming in, billions of events, and all of a sudden we realized, threat modeling is kind of the source of all that happens. We actually started threat modeling out not just our instances and our applications, but also started thinking about things like, well, what happens when somebody's leveraging SQS or S3, or what if they misconfigure something and all of a sudden there's an attack happening? How are we going to spot that? So we realized really quickly that we had to establish data collection and threat modeling in our Security Operations Center, which means our analysts are now no longer just sitting there looking at screens all day long. They actually have to participate in the workflow, and they have to understand what's actually running out in AWS. And so we've realized that that's really the heart and soul of setting up a cloud security operations center. In addition, we realized we're going to have to write a lot of rules. There's not a lot out there yet. There's not a lot of attack profiling that's been done for the cloud. There isn't a lot of information out there about what's actually happening and what we're seeing in the event streams. And so we actually had to start figuring out, how are we going to keep track of things? And so what came up was we had to have rules and alerting and have some way to flow data through the incident process. In addition, we came up with this thing called hunting, which was basically established by our partner for APTs. But we realized we had to do it for the cloud too. So we had to start thinking about how could we adapt and create some tools to go out and hunt through our accounts to find things that could become bad. And then finally, inline forensics. So the forensics talk that was right before us actually had a great discussion about how to do forensics in the cloud. We've actually had to learn that before that talk came to bear. And as part of that process, we've realized we've had to write tools, we've had to figure out things like, oh, what happens when you have to snapshot a live EC2 image? The instance is kind of going to become a problem for you. And so we've gone through the learnings of figuring these things out over time, and as we have, we've kind of come up with the notion that everything in our world for Security Operations Center centers around our tool and our capabilities and our ability to code in the Operations Center. So we're going to flip over here real quick. We have an experiment, basically, that we put together. Just a moment, please. Everything's okay. Life is good. The demo gods will be good. So I'm just going to bring this up. This is our threat analytics platform. And this is basically what we log into every day. It's a tool that we're leveraging to do correlation. Correlation is a big part of actually doing security operations and being able to deal with incidents on a daily basis. We get several hundred a day and actually have to do the triage and alerting and commenting for all of these incidents. And so if you can see here, basically, we've got a variety of information. We've kind of seeded some extra stuff in here for the demo here. And as part of this, we've got customer rules. We can put things in that we know about the account. And we've also got FireEye rules. So we've actually got things that once we've learned that these are problems, basically we can work with FireEye to establish the rules so that the community can actually use this set of rules for their own purposes. And this is kind of nice because it means that not only are we learning, but we're learning from the folks that are leveraging this platform too. So we get a lot of benefit and value by doing shared intel and also working on rules across other customers that Mandiant supports. We have billions of events like I talked about earlier, and this tool allows us to actually do some triage across the board and does some really cool things like hybrid event management. So we have some hybrid workloads, and it allows us to really think about not just the cloud workloads that we have, but when they're actually connecting between the cloud workloads and the actual hybrid workloads, we have the ability to look across our portfolio and be able to do something about it. The other thing that kind of comes up is trending, and so I've kind of pulled together some tabs here to just kind of quickly walk us through. What we really like about this tool is the ability to do timelines and be able to look at how our event stream is working on a periodic basis. You'll notice that in here we have a lot of our different data sources, and in addition, we have AWS data sources like CloudTrail. What we can see from this picture is that basically there are spikes in our event flow related to the cloud, and we have the ability to kind of pick out things that look anomalous. We're still working through this process as we speak, basically trying to figure out what peaks look like, how we actually leverage the data, but it's a really handy tool to be able to go through and determine things that make things look suspicious. Like when we have certain types of peaks in our audit data, can we correlate it back down to something happening in CloudTrail? And in this case, you can see there was a peak in the Unix audit trail, but not necessarily in CloudTrail. So that gives our analysts, the hunters, the ability to kind of go through this information and figure out more about it. In addition, we have the ability to basically build, like I said, customer rules. So as we learn things about the cloud and we do our own threat modeling, this is actually where those threats get pushed into the tool. And so as we build up our rule language and our information about what's happening in our environment, we have the ability to put things together like VPN login from unusual countries. Those are things that we start thinking about. And so we have hundreds of rules that we've started to develop because we know that there's things about how we use the cloud that make us happy and things that make us not so happy. And then you'll notice the rest of the tool has the ability for us to do summaries, reporting. We can open a case, work with each other on it. When somebody takes a shift and goes from one shift to another, they basically have the ability to transfer and comment the information on that incident. And we have the ability to do things like look across analytics. So when there's certain types of anomalies, we actually have the tool help us hunt. So this is kind of a cool way for us to know, hey, the tool has found things that we might need to actually go out and look at and have analysis for. So with that said, let's switch back.
There you go.
Alrighty, so security operations is incident response. So we talked a little bit earlier about compliance. And this is a really interesting area because we've now had to morph compliance analysis and really understand that incident response is truly its own thing. We have a ton of events and alerts that have to be gone through. We've got hunting, we've got threat analysis, we've got rule generation, all happening within security operations. And we have these other things that happen in the tool that actually flow through our event stream that we have to pick out. We don't necessarily want to duplicate that event stream. We want to actually create an event stream that can be shared from security to compliance. Compliance is actually just a derivative of the security operations capability. And really what it is we've taken our compliance checklist, we actually have alerts for those things, and we trigger the alerts so that we actually can go back to our PD customers, our business customers, and be able to understand how they are complying with regulations. We have a variety of those in the tax space. And then we also think about things like PCI. So all of those rules get pushed into our event stream, and we get real-time alerts that get pushed back to our development community. So they know in real time, are they doing good? Are they not compliant? And that basically becomes part of the process. So in addition, there's basically this set of principles we put together. We wanted our compliance operations to change and become more dynamic. We were no longer going to use just manual checklists and Word documents, but we really needed to have automated evaluations. How did we do that? We realized we had to work different. Our analysts had to code. And we also realized that we had to come up with a way to do this in near real time. Developers are pushing things out. It's constantly happening. You've got deployment scenarios that are routine and sometimes happening multiple times a day. And as when they're happening multiple times a day, you really can't have somebody scale their way into providing PCI feedback. Once a day feedback is probably necessary for somebody to keep up and maintain. Otherwise, there's a whole bunch of defects that get created. So we realized that we had to have a way to be able to triage this information and also provide education on demand. And so these were kind of interesting things. So as part of this, we've really changed our ability to do compliance. I'm going to show you a little bit about our toolkit. One of the things that we did is we established a compliance toolkit. And this is our way that our compliance folks have actually been working. Okay, this may be less friendly. Just a moment. So as part of our journey, we realized that we had to have our compliance analysts be able to code. We had to have a way to provide things like spreadsheets back to our executive community. So how do you get a spreadsheet for an executive community, deal with the dynamic nature of the cloud, and still be able to do your job on a daily basis? Well, it came down to a few things. We had to come up with cross-account roles in all of our accounts. We had to come up with tooling. We decided on Ruby because it was a pretty easy language for people to transition into that didn't really require a whole lot of coding expertise. And folks basically became able to help themselves in the compliance operations function to do these audits and be able to run these tools. All right, so let's go ahead. We have a toolkit basically that is a variety of tools. I'm going to throw this over here real quick and hopefully kind of blow it up. These tools basically are scripts that we've run. And they're a variety of scripts. So we have something called an AMI checker. We realized during shell shock that we had to have the ability to check our AMIs for shell shock. We also realized that instances needed to actually be restacked during shell shock, and that was a big deal for us. So how do you do that in hundreds of accounts? We have several hundred accounts that basically needed to have every instance looked at, every launch time. We had to be able to give a spreadsheet back to our executive community to make decisions about what we were going to do, when we were going to do it, and how we were going to do it. And so this gave us the ability to really start checking on how things were happening in the development environments across the board. Like I said, hundreds of accounts, there were thousands of instances. We had something in the neighborhood of 5,000 instances at the time. And so this was our ability to do that. We also realized we need to have the ability to check EBS volumes. We needed to be able to check elastic beanstalk, S3 buckets. So we started writing checkers, and checkers are basically anywhere from 100 lines of code to 400 or 500 lines of code. And that gives us the ability to basically create these spreadsheets in real time that can be used within our executive community and be able to provide the decision feedback that we need. We also have been working with other partners inside the company to be able to share this information and also share our scripts. So let me run our first checker. It's our AMI checker. So one of the things that we do at Intuit for doing these checkers is we also require MFA to assume a role across all of the accounts. That's an important concept. As you heard most of the time here at AWS reinvent, that it's not really good to use your root credentials. It's also not good to put credentials on your laptop that could be compromised. I'm a fan of MFA, so I actually asked for my account specifically to have MFA as well as everybody else's. And so I'm going to put in my MFA code real quick. I love Google Authenticator.
Nobody look.
Quick, quick. You're good for 60 seconds if you have my credentials. Actually, not so much. These are all test accounts. Some of them are basically set up so that we can see that there's things happening. We had a variety of instances we were checking. And so you can see in here that as the script runs, it's checking every single region that we have. It's checking the account. It's actually assuming the role. It's pulling down information. And at the very end, it will actually create me an Excel spreadsheet. Woohoo! The Excel spreadsheet has become a big hit for us because we leverage our own tools like QuickBase to create actionable dashboards to be able to work within the community. And that's been a big benefit to the company. So I'm just going to quickly switch over while that's running to show you something I put together previously, which is basically the output of that script. And you'll notice in here that there's actually an account alias, there's account numbers, there's check dates. So the check date is kind of cool because that tells us when we ran the script. We have the ability to look across the image ID, so we can figure out which images we have in play for these different accounts, the instance IDs, the owner ID, who owns these different things. We have the ability to basically determine if it's a public or private IP space. And so as part of this effort, we've realized, all right, these things are actually all cleared. So these account owners were actually cleared to continue. They didn't need to actually do anything. This was an important step for us because what we realized is we didn't have to reach out to everybody to tell them that their stuff was insecure. We could reach out to the folks that actually had problems in their accounts. We are open sourcing the checkers, yes. So let me get back real quick. And basically, you'll notice that these checklists have become really important to us as a company because it allows us to deal with the translation between a developer, here's your information, here's what's important to you, and an executive who wants to just know that things are taken care of. What's important there is the metrics that we provide and how we actually balance the information being sent to both parties. And what we're actually doing there is providing the transparency and visibility to our community.
So we're up to science now. Science by
Great Scott.
Is going to take us through science here in a minute. But just a quick note that after all of the release announcement you've seen the past couple of days, obviously this is a work in progress, and we're going to revisit some of these things. Some of this might be available with AWS config, what you just saw in the last demo, and then previously on the continuous deployment, we might be looking at code deploy or something like that. So, Scott, would you like to tell us about science?
Well, what is security science, and where does it come from? Well, we started looking at some simple principles for what security science should be. It's the death of FUD. No more fear, uncertainty, doubt. If you can't prove something, it shouldn't exist. So here's a good example. What's your password policy? Why? If you can't answer that with math, then you don't have a good password policy. How long does it take to decrypt? How many characters? If you add 4 more characters, is that twice as secure, half as secure? What is the actual math behind it? Can you prove your assumptions? If somebody downloaded your entire password file, how long would it take them to crack? Are you using algorithms that are GPU enforceable or not? These are questions that can be answered by science. So our idea is we started doing things like making us rely on real data, making us prove the assumptions that we have about things, and then modeling our solutions. If we're going to do something one way, how can we prove it? And most importantly, how do we then provide tools that our PD teams or development teams can actually use to make intelligent decisions? Next slide. So to make sane security decisions, like how frequently, as we already talked about, how frequently should somebody restack? Well, what are you using? If you're using certain RPMs or certain distributions, what is the mean time between CVSS vulnerabilities 5 or higher? Nice. If you're going to have to restack every 3.5 days, because there's so many vulnerabilities, what happens if you changed your database from MySQL to Postgres? Is that better or worse? What happens if you stopped using PHP and started using Ruby? Is that an improvement in your security decision or a problem? If we can give modeling tools to our user community to help them make these decisions ahead of time, so instead of them coming up and saying, I've got a failing grade again, what am I supposed to do? I updated yesterday, why am I failing today? Well, there's a new vulnerability. Well, how frequently does this come out? We want to answer those questions. So by finding this information out, by uncovering this information, we can then allow our communities to make better decisions. And our whole goal is to be able to uncover new threats and new vulnerabilities in the wealth of data that we already gather. Next slide. So one of the things that we did with our development team is that we started working on tools. Keep going because we're running low on time. So we were doing things like, if we could pull all of the information from all of our accounts, what are our instances doing? What RPMs are installed on them? What operating systems are they using? What's the frequency of their updates? Are they actually doing security updates in real time? Are they doing it via cron? Are they doing it only at boot? Take a look at what's going on in their CrowdTrail accounts. Take a look at what's happening in their Amazon accounts. Being able to ingest all of this data and then provide it to a way that we can visualize and show it to people in a way that makes sense to them. So we were talking about things like a score. If you got an F, you'd want to improve that. If you suddenly woke up today and they said your security score is failing, you want to fix that. So you start doing the work to fix the failing score. Now you've got a B. Well, how do you get an A? What we wanted to do is then take the op mix of successful teams. These guys keep getting A's. Why don't you follow what they're doing? Here's the difference between what they do and what you do. So if you start using their op mix instead of yours, if you instead of patching once a week, you're patching nightly, if you reboot all of your instances and restack them every 12 hours with the latest AMI constantly, are you more secure? What's your uptime in relation to that? Is your system stable? Those are the insights that we want to give to our PD teams. Next slide. We also started looking at things like egress monitoring. How do we know what's going on in our instances, and how can we actually detect and protect them? So we're starting to use things like OpenDNS to make sure that we don't have outbound connections to C2 networks, so that if somebody does compromise one of our machines, we can prevent them from reaching out. Furthermore, you can then start gathering data, not across one account, but across hundreds of accounts, and be able to see what all of our users and all of our instances are doing across all of the different platforms. This sort of information becomes invaluable for us to actually do trend analysis and do data discovery.
So with that science,
Thank you.
We've talked about leveraging our community of vendor partners, leveraging the community itself, talking about DevSecOps with the ability to have security engineering, security operations, compliance operations, and science all work together in uniformity to provide our developers the ability to make decisions about security, how to keep their risk low. Have we met our objectives? It looks like we have. It looks like we've actually established a customer-focused mindset, scalability, the ability to determine objective criteria through scoring and creating grades, the ability to do proactive hunting through some of our tooling, and then finally, continuous detection and response. We respond 24/7.
So the best way to get started is simply to get started. Just dive in and start coding. Pick an SDK that you think will work for the entire team. Choose a language and get going. If you can't think of some problems to solve, we've written up some examples for you, some exercises for the audience. If you've got a multi-account enterprise, then ask yourself how you're going to ensure consistent security configurations across all your accounts. How will you detect and respond to configuration drift? How will you correlate and mine security data across all of your accounts for the full stack? How will you gather compliance artifacts that are needed for your regulatory requirements? And we've got some additional resources here. DevSecOps.org is where we will post the DevSecOps toolkit a little bit later today. And it has a link to the GitHub site there as well. And as always, check out the Amazon Security Center as well as the Compliance Center. So some other related sessions, some of these are completed and you can catch them on YouTube later if you didn't catch them already. But coming up, these are some good-looking sessions, architecting performance and security in the hybrid enterprise, mastering access control policies, and my personal favorite, architecting for end-to-end security in the enterprise. Thanks very much for everyone coming today, and please give us some feedback. Thanks.
Thank you.